So next up, I'd like to introduce to you Norhan Bayomi. Norhan is the co-founder and chief operating officer of Lamarr AI. She received her PhD from building technology from MIT last year and a master's as well. She's also a postdoc fellow at the MIT Environmental Solutions Initiative and lead researcher at the Urban Metabolism Group. That's such a cool name. I'd love to learn more about that, what that is. Her research fuses artificial intelligence, design, and technology to tackle problems in the built environment. I saw her pitch at the DesignX Accelerator, Venture Accelerator last year, and was just blown away by the innovation in vision. I mean, she'll talk about this in detail, but she has a system that quickly scans the exterior of a building to determine its energy efficiency, and it does it through drones and AI. So amazing. And it's as fast as an MRI scan for the building. I love that analogy. I don't love MRIs, but I love that analogy. Through an automated workflow, Lamarr's technology provides actionable data for retrofit strategies that architects and urban development stakeholders can use immediately. So can anyone guess why the company's named Lamarr? Anyone? Hedy Lamarr. Okay, wonderful. So let's bring Norhan up. Welcome.
Thank you so much for the introduction, and thanks to everyone who came today. This presentation is very special to my heart. Besides, this is the company that came out of part of my PhD. It's also like an output of a research project that started in 2016 with a passion of how we can utilize drones for the built environment and how we can leverage the power of artificial intelligence. The main motivation behind this technology initially started with that climate change is posing a lot of risks right now, with more climate effects are increasing in magnitude and frequency every year, and that poses a lot of challenges on the built environment. In addition that, we need to identify how we can invest in the built environment to be able to improve their efficiency within the next coming years. The Department of Energy predict that there would be around 10 million buildings be added in the US building stock within the next 10 years. And these buildings are expected to perform with higher efficiency, but at the same time, we have buildings that are aging and their performance are degrading over time. With climate policies, we see a lot of changes happening on the positive sides. So there are a lot of code that have been developed over the past couple of years that would require mandatory reporting for buildings for their energy and emissions. Similar to Local Law 97 in New York and Purdue 2.0 in Boston. The construction market is also heading in that direction, how we can improve efficiency. So 61% of the construction projects that took place last year were retrofitting projects. And also predictions indicate that the envelope retrofitting industry is expected to double in size this year. But the problem on the ground is much bigger. So like I mentioned, 50% of the US building stock is built before the year 1980. And these buildings are currently performing with lower efficiency, and it would require a lot of retrofitting efforts to be put in place within the next coming years. On the positive side, there is a lot of opportunity to save energy by improving these buildings, as by only retrofitting the building envelope, we could save around 40% of the energy used in buildings. However, the process with how we can identify the right retrofitting strategies is right now completely manual. So how it's done right now, it's a completely manual workflow where you have site plans, you hire a building auditor with a handheld thermal camera. Now it's started to change with more use of drones that become more accessible. But the idea that the building auditors start to take these images manually, and then they go through all these images, each one individually, to identify which areas are considered problematic. Also, there are some cases like the picture in the middle that you utilize some very time-intensive and cost-intensive tests like the blower door test, which actually would require complete evacuation of the building to be able to identify where the leakage are, and then finally report findings to key stakeholders. This process usually could take around 3 months for a building of 20,000 square foot, which is a very time-intensive process. After the data collection, the analytical side is still also very manual. So usually the data are handled by building scientists who go through all these data and develop simulation model to be able to give some sort of an understanding what are the right retrofitting strategies, and what is the return of investment on these strategies. And that also is a time-intensive process that does not scale to the current market need. So what we developed in Lamarr is basically we wanted to understand how we can leverage the power of drones and the automation with AI, similar to give your building an MRI scan, which is like the analogy that we have identified through the research, because looking at these images is basically looking at an MRI scan for a brain where you see the problematic area, but we're not detecting tumors, we're basically detecting anomalies. How our technology works. So our technology consists of 3 key components. The first one is the data collection with drones. So over the past years, we have been developing the right flight path that are suitable to collect the data with RGB camera and infrared camera. So we do 2 flights separately. And then our proprietary computer vision and machine learning model basically identify where these anomalies are and classifies them. So this is the innovation in using computer vision, that we collected thousands of data that were labeled by building scientists who are expert in that space. And then we tested the performance of the model to identify that the model can accurately predict the classes of each anomaly. And then finally, the most important step, that these anomalies are translated into geometry that are registered to a digital twin that could be directly integrated into building simulation models to identify the right retrofitting strategies and evaluate return of investment on these strategies. So right now, our service kit consists of 5 key components: flight planning, data collection, image processing for both RGB and infrared data, geometry construction from photogrammetry, and finally, energy modeling. I'll just show you a quick, this is a video from one of the flights that we did. We worked with community groups in New York. We also work with the campus facilities in Georgia Tech and MIT. This is one of the buildings in Georgia Tech that we tested the entire workflow to identify how fast or accurate we are compared to the traditional methods, up to the registration of the anomalies, which is the geometry you see here. Also, we have been developing kind of a prototype of a software that could be used by regular homeowners who are interested to inspect their buildings and identify where the problematic areas are, where you can just capture any thermal camera with even an IR flare extension for an iPhone, and you can upload the images directly to our software and can tell you exactly in each image where are the anomalies and what type of anomalies this is. And this is very fast, so it can process 1,000 images in 2 seconds. These are some of the expert study that we have done. This is one of the data that we collected in Georgia Tech, where we validated the model performance using expert opinion to identify how the model can accurately predict. And right now, our model can predict the accuracy with 89%. So with this process, we basically cut down how it's done right now. So like I mentioned in the beginning, it could take around 40 to 20 days only in identifying the right building auditor, up to additional 50 days to do the data collection, and just to deliver some information within 2 months. With our technology, we cut down this process, and basically we can cut down the entire process into 1 week for a typical building of 10,000 square foot. So through these pilots, we have identified and confirmed that our technology can save around 85% of the time spent in a traditional building audit. It's also much cheaper. So it's 90% cheaper compared to the traditional building audit that's been done right now. But most importantly, we are safer and more accurate because we're using drones, and we're cutting down any kind of safety concerns that building auditors might face in high-rise building or even other conditions. So for our competitors, we are at the top of the autonomous processing compared to these 3 components, which is the aerial data, thermal inspection, energy modeling, because our software kind of integrate all these 3 components in one single platform, and it's fully automated. How we have been looking at our revenue model. So right now, we're more on the subscription-based model for large property management companies who are our key clients, where they can collect the data and get diagnosis more on time, and then can get some recommendations on what type of repairs could be done, the return of investments on these repairs. Also, some standardized reports on code compliance requirement. Our next step is transitioning to do-it-yourself market, so working directly with homeowners using the Lamarr app, which is currently in development, where people can capture any kind of imagery with FLAIR, mobile camera, or a handheld thermal camera, not necessarily drones, because our model also works with handheld data, and they can get some repairs on what type of material that they could use to identify their building's performance. So this is just an example of one of the projects that we have done. This is actually our first client that we have worked with, which is a property that we inspected 13 buildings in Tampa, Florida. And as you can see, these model here, basically an output directly from the computer vision and AI that can tell you exactly which windows have leakage in which floor and which side of the building, and also where are the locations of any missing insulation. And we use that information for thermal energy modeling, which is the table you see on the top, where we can identify how much HVAC energy use saving that you can improve by tackling these anomalies. So with this project, we identified that this technology could be also very useful for decision making, because if you have a property of 20 buildings and you want to see which building that you want to prioritize in your intervention, you could also benchmark buildings against each other with respect to anomalies, areas, and number of occurrences in each one. And we have identified through this project specifically that could be some group of clustering of buildings that are considered performing well, and others that are at the edge of lower floor efficiency. So this project was particularly interesting for us to showcase, because these are the same building that were constructed by the same contractor, the same construction company. They are situated in the same setting. So we were wondering what really caused this large deviation between some buildings are at the top of lower performance and some buildings are performing much, much better. So that goes back to the climatic factor and how much each building is exposed to sun and different situations, and also the use of the building and the operation. So our use case actually cut down the time that would spend for a building like this, a property like this, from 6 months, and we completed this in 1.5 months. It was a very interesting project for us because we took the technology from the research project and we wanted to understand how we can make it an actual product that people can use. And that was a very good exercise for us to really understand how we can automate, how we can improve the output, what does the data look like, how the client could actually use the data. So that was a very interesting project for us. So this is just some of the accelerator program that we took part in. We won the US Department of Energy American-Made Challenge last year with another robotic company called Flex, where basically you take the information from our technology and there is a robotic arm that go inside the wall and basically do the insulation repair real time. Our team is very diverse from building technology, urban analytics, machine learning, and computer vision. And we believe that we came together with the right skill set to tackle this problem that we're facing. And this is the same team that started the research that was funded by the Department of Energy 6 years ago. Right now, we have four employees full-time. 2 of them are actually MIT fresh graduate who joined us during the research and are continuing to work with us. Just finally, I want to say, like, we named this company as a tribute to the actress Hedy Lamarr. She's an inventor of the signal hopping technology, and some of you who are not familiar, she didn't gain any credit for her technology invention during her lifetime, so we are dedicating this company to her legacy and all inventors who didn't gain prominence during their time, especially women. So we believe with our technology, we can revolutionize how building performance inspection are being done right now. So thank you so much for listening, and happy to take your questions after. Thank you.
All right.